Quadratic functions in all three forms and how we can model data using a quadratic function. If you look at the data in the graph here, it's showing you the path of a home run baseball relative to its distance from where it's hit. So if you look, it seems to be increasing and decreasing. It appears to be somewhat symmetric about this point here. You can look at the data in the table. It's increasing horizontally. Vertically, the height's increasing, it decreases. So it appears to be a somewhat quadratic motion. Is it perfect? No. Will it have a maximum or a minimum? It's really actually going to have it's going to have both. We're really looking for the answer maximum there because it does have a maximum height. It's a quadratic, or it appears to be a quadratic opening down. It does in fact have a minimum because there are two zeros. We can't have the ball go below 0, but in this situation we were looking for maximum. What's the approximate maximum height reached? It looks like it's about 27 meters, and we can figure that out by drawing a horizontal line across to the axes. We've used a scale of 2 meters for the height, and we're halfway between the 26 and 28 mark approximately. The distance traveled by the home run ball, each box across the bottom, each horizontal box is worth 20 meters. So this is actually 140 right here. Halfway is 150. That's pretty close to 160, so I would guess 157 to 158. The last thing I want to know is, can I model this using a quadratic function? Does it look like a quadratic function that opens down? It does. Is it perfectly symmetric? No. If I draw a vertical line, that's my axis of symmetry. If I compare the distance from the first 0 to the axis of symmetry and the second 0 to the axis of symmetry, it's not perfect, but it's close, and we can create an approximate equation using that data. In class tomorrow, we're going to create an approximate equation for the path of this home run baseball in vertex form, in factored form, and then we're going to use the TI inspires in order to come up with the true regression equation to model this baseball's path. And before you come to class tomorrow, try and do exercise 7, pages 13 to 14, questions 1 ABC, 3 AB, 5 AB, and 6 ABC. Thanks.